Welcome to an information session on electrical and computer engineering technical electives. This is focusing on getting into the fall semester sequence of courses, but as you're planning, you probably do need to take a full year or year and a half in advance, and maybe even 2 years, as you'll see in a minute, in preparation for taking your elective courses in electrical and computer engineering. And a lot of times when I start this information session off, I preface it with the following question. Do you know what you're going to be doing in 5 or 10 years? And maybe we don't, but what we can do is we can prepare, and we can prepare by laying a strong foundation of foundational or fundamental electrical and computer engineering courses that will propel us into the next 5 years, 10 years, 20 years, and beyond. And that's what you're wanting to accomplish by the selection of your technical electives. And as you're doing this selection of technical electives, you might be helped by the following image that's on the screen that's illustrating what you've already taken or will take shortly in terms of your coursework in electrical and computer engineering. For example, you've probably taken ECE 175, the programming class, and 275, and you can see those listed on the right-hand side of this line that's now broken up into decades. Those classes are in the 70s in terms of the decade of the 70s, and we've tried to organize our coursework into decades of numbers. And so the computer engineering or courses related to computers, most of those you'll find in the 60s and 70s. So if you're taking 372, 373, etc., those classes, and if you enjoyed those classes, or you know that you need to really put a little bit more effort into classes in that area, then that too could help you decide what you want to take or select for your technical elective courses. And you can now see how I've labeled, hopefully, these other decades. You have signals and systems classes in the 20s, 30s, and 40s. Signals, ECE 220 and 320. Those are circuits and circuit theory classes. Those naturally lead into signal processing classes that are going to have the 20s possibly as their decade after the 4 and the 5. So 429, 529, that's a digital signal processing class in the 20s. The 30s is communications, and the 40s is control. Electronics, those are in the 50s. You'll have already maybe taken 351C. If you're in electrical or if you're in the electrical engineering track, you will take 352. But if you're in the computer engineering track, if you want to learn a little bit more about device physics, you could take that as a technical elective course. And then we've already talked about the computer, but the electromagnetics area, how do waves propagate? That's in the 80s. Now, as we get started into this, you'll want to be looking at what are these courses, and there's a couple of links here provided for the syllabi for the undergraduate courses and the graduate courses. And in those syllabi, you might look at the textbook, the description of the class, the topics that are going to be covered, and what are the prerequisites for that particular class. Those will help provide you with a picture of what it is that this class is addressing and what you might learn in that particular class. And as we're going through these, you're going to see that I'm including 500 level courses. And that's okay, because undergraduate students can take graduate courses. They could either do it for undergraduate credit or for graduate credit, but they might start then at the main website for the University of Arizona, and in the search box, you could now take or type undergraduate enrollment in graduate classes. And that will then take you, or if you follow the appropriate link, that will now get you to this website that now coaches you through how to either receive undergraduate credit for those 500 level classes or to receive graduate credit for those 500 level classes while you're still an undergrad. And you'll need to fill out this form. If you are wanting to put this towards your undergraduate degree and you don't need graduate credit for it, and it's a 500 level class, then you'll need to be a senior or a junior honor student, have a GPA of at least 3.0, get the course instructor's approval, and then submit this form. That's the process, and it's not that onerous to obtain a undergraduate credit for a graduate level class. The other thing that you might, in addition to the course syllabi, you could actually go and look on the U of A website in the catalog. If you go to catalog.arizona.edu, follow the courses menu, well, down to, if I would quit clicking on course descriptions, now you can follow that to the ECE, or electrical and computer engineering. Now that you're here, you can click on view all course descriptions. And as long as you block or allow pop-ups, now you will see all the course descriptions in electrical and computer engineering. And this now gives you a quick description of what that course is as you're looking through and trying to decide, what do I want to take for my technical elective courses? And for example, if you're an electrical engineering major and you go, oh, maybe I do want to understand a little bit more about computers and how they're organized or how they're built. Maybe I do want to take 369A as a technical elective, and that is possible. Now that and the other thing, as you're looking at these classes, you may see a particular instructor listed. That could change, but hopefully not too many times it will change, but it could change. But if you wanted to understand or a clearer picture about what that faculty member is pursuing research-wise, you could watch their video at the following link. And I'm not sure if I put that. I did find that. So here is that page, and now you can go and examine or learn a little bit more about the faculty that you will be experiencing in the classroom as far as their research and what they're doing here at the University of Arizona. That's enough for sort of laying the groundwork. Let's get into what hopefully will be available to you for the fall semester. And here I've labeled next to these 300 level classes EE. If you are in the electrical engineering track, you will be able to take 369A or 373 as a technical elective course. And I've already talked a little bit about computer architecture, object-oriented software design. Now you might get into data types, classes. It might be taught with the Java programming language. If you want to learn that, that would be then covered in ECE 373. If you actually want to learn a little bit about neural networks, modeling, physics, physical systems, biological systems, that's 411, 511. Web development, how do you design a website and then connect that with all of these wearables or different devices? It doesn't have to be a wearable. It could be your refrigerator. It could be something else in your home or car. Everything is starting to get connected. That's this Internet of Things, or IoT. How do you now merge that with a website, develop the website? That's 413, 513. If you liked your digital logic class with the FPGAs, now you might look into taking computer-aided logic design. So right now I'm talking about the computer-related courses, and you can see that we've run out of room in the decade of the 60s and the 70s, and so we have had to use some other decades to allow for introducing new courses. But if you liked 274, you might now step it up a notch and get into 474 and 574A. And if you're in the AMP or thinking about the Accelerated Master's Program, which we will talk about at the end, you would then be taking a 500 version if that was one of your 4 courses that you're trying to double count towards both your bachelor's degree and your master's degree. You would want to be enrolling in the 500 version of that class. If you wanted to understand how computers are interconnected and building networks of computers, that's now 478, 578. We're getting everything now moving around in computers. Maybe we need to worry about security. 509 deals with cybersecurity. What are the concepts? How do you implement that in practice? I'm not sure if 576A will be offered. Sometimes it is, sometimes it is not. But now, how do you build computer-based systems, worrying about the hardware and the software aspect? And you'll get into probably a little bit of artificial intelligence, some simulation, knowledge-based systems with this 576A class. Moving now into the electronics, the bio classes, 434A. This is now electrical and optical properties of materials. What do we have? We have conductors, we have insulators, we have semiconductors. How do we build these systems having certain properties, and how do we model those or analyze those? Analog integrated circuits, that's 450, 550. How do you physically start reasoning with circuit fundamentals? How do you build things up? You've hopefully 351C, you would need that at least to step into 450, 550. But now that you have that, how do you build more complicated electronics from these basic fundamental building blocks that you learned about in 351C? In 472, 572, now this is design, modeling, and simulation of high-tech systems in medicine. You might think of the Da Vinci robot or the hospital environment. How do we allow these complicated systems, high-tech systems in the medical arena how do we design them? How do we model them? And how might we simulate how they will function? If you're an electrical engineer, even if you're in the computer engineering track and you want to look at this concept of optics or learn the fundamentals of optics, and I really can't stress this enough, you probably don't want to over specialize with your technical electives. You probably want to look across more than just one of these sub areas within electrical and computer engineering. So you probably do want to understand some optics before you graduate, and this class would help you start to get into that particular part of engineering in the form of optics. Microwave engineering circuits, these are passive circuits. Now, how do you talk about transmission line, filter design with passive circuits, holography and diffraction? Now you're worried about interference. 696B, that's now introduction to quantum mechanics and quantum information processing. If you're interested in learning a little bit about quantums, that would be a good class to move into. The last category is this signals and systems area, the 20s, 30s, and 40s decades. You could, as we talked about, take a digital signal processing. Maybe you've not seen that before. Maybe you've been working with analog signals. Now, how do you design filters that are digital filters? And now you can put these into devices, into computers or embedded systems. How do we do Z transforms? You've probably learned about Laplace transforms. Now let's do something similar for discrete time systems, and that's now digital signal processing. If you liked 340A, Introduction to Communication Systems, now you can look at it from an optical perspective and say, oh, how do we communicate or build communication systems out of optical material, fiber optics, etc. Digital image analysis. How do you, if this would now be a step beyond digital signal processing, so you want to look at these prerequisites, but digital image analysis is what's in this image. Can I identify borders or edges? What's in this? How do I analyze this image? I'm not sure if free space optical communication systems will be taught, but again, that's saying, oh, how do we communicate with optical devices in free space? Digital communication systems, that now goes above and beyond the introduction to communications and digital communications. Digital communications is 435, 535. So now this could be maybe if you have another semester in your senior year, now maybe you have already taken 435, 535, and you want to go the next step in digital communication systems. Radar signal processing. Now, how does radar work now that we have all this self-driving cars, etc.? How do we work with radar signals and process those signals to obtain meaningful information? Automatic control systems. How do you model a system? Now it's not just circuits that you're talking about modeling, but it could be mechanical systems, electromechanical systems. How do you model that? If the system isn't behaving the way that you want it to behave, can you change that by introducing another subsystem, a controller, and close the loop? And now you have a system that behaves the way that you want it to behave. Advanced linear systems theory. This is now linear algebra transitioning from a finite dimensional setting to an infinite dimensional setting. So you're laying the groundwork of maps and operators, inner products, eigensystems, so that you can understand that at the basic level in finite dimensions, but going with this advanced word is we want to lay this foundation in a more general sense so that you can now understand it in an infinite dimensional setting. If you're interested in probability and random processes, there's noise everywhere. How do you deal with that? How do you model it? That's now probability and random processes. Detection and estimation. This is now another in the communications area, but how do you detect signals? How do you estimate what you are detecting or work with what you're detecting to model those? And as I said before, you may want to be thinking more than one semester ahead. And the reason I say that now is if you're interested in entrepreneurship, you might want to think about taking this McGuire program of a 2-course sequence. The Venture Development 1 is in the fall and the Venture Development 2 is in the spring. This actually conflicts with the time of the capstone in engineering. So if you're interested in entrepreneurship, I would really strongly encourage you to do that in your junior year so that you can take advantage of these 2 courses, and it's a 1-year combination. We allow those 2 courses to be counted as 2 of your available technical elective courses. As you're planning your schedule, here is right now what we are seeing for when the different courses are being offered. And now what you'll want to do is not get your heart set on taking 450, 550, and 459, 559, because those are going to be conflicting. You can only take one in a given time interval, but this now allows you to look at when these courses are taught and map out the 4 or 5 different electives or 3 different technical electives you're wanting to take in the fall semester. Again, that's the fall, but you really want to be thinking long-term or a little bit longer than one semester. So now let's quickly run through what might be available in the spring semester. We have computational techniques. That now is talking about, how do we numerically integrate, differentiate, and if you're interested in genetic algorithms or simulated annealing, maybe even some optimization, that would be a class that you could learn that material from. Computer architecture. Now, how do we follow on from what we've learned in ECE 369A? How do we design, and what are the trade-offs if we want to enhance certain aspects of the computer and the computer architecture to make it more efficient, maybe more powerful, etc. Fundamentals of information and network security. Again, this is getting into the cybersecurity idea, but this is coming from cryptography. If you want to understand how do we encrypt information, how do we decrypt it, principles of artificial intelligence. If you're interested in artificial intelligence, that's 479, 579. Reconfigurable computing. Now, how do you build such systems? What are some of the challenges? What does that even mean? I would recommend that you go to the different websites and look at the course description, look at the course syllabus, and then if you still have questions, email the instructor that's teaching that class and see if you can get a little bit more insight into that particular class. Fundamentals of cloud security. Again, how do you secure this information that is flowing all around us in the cloud? Wireless protocols, I'm not sure if that one will be offered, but again, keep your mind open and stay flexible to what you might want to pursue, and spread it broad so that you now have many different opportunities in the next 5-10 years. If you're in the computer engineering track, you could take device electronics, ECE 352, and that now deals with the PN junction, etc., and carriers, what's carrying the information. 407, 507, now how do we design these digital systems in an analog world? So how do we build MOSFETs, CMOS, inverters, logic gates? That's 407, 507. If you're interested in how do we actually measure physiological systems, then that's 417, 517. That one's a little bit challenging maybe to get into. That's a high demand and it's required in biomedical engineering, but maybe there's a chance that you can get into that. If you're interested, again, if you're a computer engineering track, you could take electromagnetics. If you were always interested in Maxwell's equations or seeing electrostatics and magnetostatics from an engineering perspective, not just the physics perspective, 381A would be a good class. In that same general area of electromagnetics and optics, we do have or offer a photovoltaic solar energy system. How do you design these solar cells to be more efficient? How do we capture as much energy as possible and then use it to our benefit. Optoelectronics, what's this connection between optical subsystems and electronics? How do we put those together? If you're interested in how all of these devices communicate, how do we build antenna? How do we design them? How do we continue to evolve these devices? That is then going to be covered in antenna theory and design. And I'm not sure about the advanced topics in optical and electronic materials, but again, that would be something similar in advancing the relationship or this connection between electronics and optics. In the signals and systems area, if you're interested in machine learning or data analysis, that's 523. Digital image processing, now can we do filtering with digital images? How do we do that? Digital communications, again, I hinted that that was a necessary course before stepping into 537. Now 435, 535 is the next step beyond ECE 340A. Now you are going to be worrying about how do we translate this information content into a digital setting and worry about the channel. How do we now decode that information? That's now digital communication systems. Digital control systems is a class dealing with control, modeling, analyzing, changing the behavior of a dynamical system, but now you're doing it in the discrete setting, discrete time setting. So now you're using Z transforms. This is disconnected technically from 441A or 541A, but if you've already had an analog control, now you'll see what you were doing in the analog signal world in the digital signal world. And maybe this course in quantum information processing or quantum error correction will be offered again in the spring. I'm not sure. So that's why I'm saying here, as you're laying out your courses during the spring semester in a year, this is a tentative schedule for selecting what courses you might take. And now you'll want to, you can see that it's fairly busy on Tuesday and Thursday. And so now you don't have every possibility or every combination. You're going to have to pick between one of these 5 classes, for example, that are listed in the 11 o'clock to 12:15 time frame. But this will now be how you could potentially start to lay out your spring schedule. That's the technical elective component of this information session. There's also a piece dealing with the accelerated master's program. And this is a good program. It allows you now to obtain your bachelor's degree and your master's degree in as little as 5 years. What we're allowing you to do is essentially count up to 4 courses towards both your bachelor's degree and your master's degree. And what you'll need to do is, if you decide to do that, you'll need to make that choice and apply in your junior year. And this is what it looks like in terms of a 5-year plan. Now, these orange blocks, 4 of those are taken in your senior year, and those 4 count towards the first 4 years of your engineering program, which make up your bachelor's degree. And then a graduate degree, a master's degree, consists of 10 courses, but now you're able to count 4 of those that you've already obtained in your senior year towards your graduate degree. And now you have 6 more graduate courses to take to fulfill your master's degree. And now you have completed your BS and MS in 5 years. So as I said, the admissions requirements, you need to be a junior or senior. You need to be a strong student. I have a cumulative undergraduate GPA of 3.3. One of the benefits of getting into the accelerated master's program is you now don't have to take the GRE exam to get into the graduate program. That's being waived. And after you've now finished a minimum of 75 undergraduate credits, or roughly your second semester of your junior year, that's when you could submit your application. You now have to wait until you have obtained 90 units. Then you can start enrolling in these 500 level classes that will count towards both your BS and your MS degree. And if you have questions about the AMP, you can contact our graduate advisor, Ms. Tammy Whalen, and get help with that particular process. I hope this has been helpful. And again, check out the different resources that you have available to you. You can look at the syllabi, you can look at the course descriptions, and you have more than just 400 level classes to pick from. If you're a strong student, you can also take 500 level classes and count those either towards your undergraduate degree or for your graduate degree. And if you're in the AMP program, you can actually count 4 of those 500 level classes towards both degrees, your BS and your MS. Good luck with your decisions and good luck with your engineering degrees.